Ever wondered how secure your favorite apps are? Could they be a hacker's paradise due to insecure coding? Imagine the apps you use daily, potentially riddled with weaknesses, just waiting to be exploited. This, my friends, is the world of app vulnerabilities and insecure coding, a realm where the smallest oversight can lead to the largest breach. The importance of secure coding cannot be overstated. The risks? Well, they're as vast as the digital world itself. Stay tuned as we delve into the process of identifying insecure coding. Insecure coding is not just a term, but a gateway for potential threats. But how do we identify it? Let's peel back the layers on this concept. Insecure coding, in its simplest form, is a set of practices that can leave your application vulnerable to attacks. It's like leaving your house's front door unlocked, inviting potential threats right into your personal space. Now, to understand insecure coding, let's dive into some common examples. First up, we have the lack of input validation. This is akin to accepting any stranger who knocks on your door. In the digital world, when an application doesn't validate or sanitize the inputs it receives, it opens the door wide for malicious inputs. This could lead to devastating effects like data breaches or system crashes. Another example is improper error handling. Imagine driving a car without a functioning dashboard. You wouldn't know if you're running out of fuel or if your engine is overheating until it's too late. Similarly, when an application doesn't handle errors properly, it not only disrupts the user experience, but also provides valuable information to hackers about the system's inner workings. The third example is poor memory management. In the world of coding, memory is a precious resource, and poor memory management is like a leaking faucet, wasting water drop by drop. It can lead to performance issues and, worse, security vulnerabilities. When a program doesn't release memory once it's done using it, it can cause what's known as a memory leak. Over time, this can slow down the system and even crash it. Moreover, poorly managed memory can also be exploited by attackers to execute malicious code. By identifying these examples in our code, we're taking the first step towards better app security. It's like learning the weak points in your home security system so you can fortify them against burglars. Identifying insecure coding is the first step towards fortifying app security. Remember, in the realm of cybersecurity, knowledge is your best defense. So, let's continue to unveil the mystery of insecure coding in the upcoming scenes. Now, let's unravel the step-by-step process to identify insecure coding. To uncover insecure coding, one must embark on a three-pronged journey. The first stop is code review, the second, automated static analysis, and the third, dynamic analysis. Let's explore each of these in turn. Starting with code review. This is a systematic examination of the source code of an application. It's like proofreading a novel, but instead of searching for grammatical errors, we're hunting for security vulnerabilities. This inspection is carried out by a team of experts who meticulously comb through the code to spot potential security risks. However, one must remember that even the sharpest eyes can miss a needle in a haystack. Hence, the process doesn't end here. Next, we dive into automated static analysis. Imagine having a robot that could scan through your code and point out the weak spots. That's exactly what automated static analysis does. It's a tool that systematically checks your code for common security pitfalls, such as buffer overflows or SQL injections. The beauty of automation is that it doesn't get tired or distracted, ensuring a thorough and consistent analysis. The final destination on our journey is dynamic analysis. This is the testing of the software in a running state. It's akin to test driving a car rather than just inspecting it in the garage. Dynamic analysis can uncover vulnerabilities that may not be visible in a static state, such as runtime errors or data leaks. Each of these steps is crucial in its own right. Code review provides the human touch, catching contextual errors that machines may miss. Automated static analysis ensures consistency and depth in the inspection. And dynamic analysis tests the application in action, revealing vulnerabilities that only surface when the code is running. With these steps, one can spot and rectify insecure coding, strengthening app security. Insecure coding is not to be taken lightly. The dangers are real and potentially catastrophic. Picture this: you've poured countless hours, resources, and creativity into developing an application. It's sleek, efficient, and user-friendly. But lurking beneath the surface is a sinister threat: insecure coding. This hidden menace can wreak havoc in a multitude of ways. For instance, data breaches. Insecure coding can leave your application vulnerable to hackers who are always on the lookout for weaknesses to exploit. A single breach can expose sensitive user data, financial information, and even proprietary business secrets. The fallout from such an incident can be devastating, resulting in hefty fines, lawsuits, and irreparable damage to your company's reputation. Next, consider unauthorized access. Insecure coding can provide cybercriminals with a backdoor into your system. Once inside, they can manipulate data, alter functionalities, or even take control of the entire system. It's like handing over the keys to your kingdom to a malicious invader. Finally, let's talk about user trust. People rely heavily on applications for their daily activities. If your app is compromised due to insecure coding, it can lead to a significant loss of user trust. Trust, once lost, is hard to regain. Your users might never feel safe using your application again, leading to a drastic drop in user engagement and ultimately your bottom line. Insecure coding can turn an app into a ticking time bomb. So, we've explored insecure coding, how to identify it, and its potential dangers. We've journeyed through the labyrinth of insecure coding, shedding light on its dark corners. We learned that it's not just a bug in the system, but the result of overlooked vulnerabilities and lax security measures. We've also delved into the process of detecting insecure coding, using pen testing as a tool to poke and prod into the system's vulnerabilities. This method is not just a test, but a necessity for maintaining robust security. We've seen the potential harm that insecure coding can cause, from data breaches to a complete system shutdown. It's a ticking time bomb waiting to explode without warning. But the most important takeaway is the absolute necessity of secure coding. It's not a one-time task, but an ongoing commitment to safeguarding user data. Constant vigilance, continuous testing, and regular updates are the key to keeping our systems secure. Remember, secure coding is not a one-time task, but an ongoing commitment to safeguarding user data.